Okay, 好。So okay, let's keep trying. Okay, maybe it doesn't work. Maybe we should change the room. Okay, to 204. Okay. Okay, so yeah, I have said that the past 2 weeks we already, use the Lewis structure, right? Okay, fit the octet rule. Try to figure out the molecular structure of molecules, right? Okay, then later we find it's only fit for the period 2. Okay, 第二周期, right? Then there's a theory named VSEPR. Okay, use what? Use the unpaired electron repulsion. Okay, to predict the structure of molecules. Okay, so but then they find the VSEPR is not fit. It doesn't fit into the, for example, the transition metal complex. Okay, because it's more than for the transition metal, they can coordinate. Okay, coordinate with 6, 7 at okay 10, 9 ligands. Okay， 也就是说过渡金属因为它比较大，电子多，所以它可以跟很多的 ligand 一起做配位。Okay, then finally, okay, the chemist or physical chemist they reorganize another theory about the orbital bonding orbitals. Okay, so we talked about this a little bit before. Okay, remember orbital, not orbit. Remember? Orbital and orbit. Okay, both nuclear model. They say, oh, okay, electron, running circularly around the nucleus, right? And there is the orbit. Okay, it's because it follows Newton's the classical physics, classical mechanics, 古典力学. Okay, so if it follow orbital rule, finally they will what? They will hit, the electron will hit the nucleus. Okay, so then in chapter 12 we say, okay, the modern chemistry, modern physical chemistry or quantum chemistry, okay, what do we call? It's the orbital. It's the area. 轨域. Okay, so electrons show up in the space. It's based on what? It's some kind of probability. Probability 几率. Okay, so we use the Schrodinger equation to do everything. Okay, right? Integration of the whole space. Okay, so we know, oh, okay, S orbital is like a ball, right? The atmosphere is a round ball. Okay, and P orbital is 2 law. Okay, D orbital is what? 4 law, double law. Or the D square is what? The single law with the what? Donuts. Circle of the dots. Okay, so yeah, so here in chapter 14, we will keep use this orbitals theory to describe the covalent bonding. Okay, so here, for example, okay, we can use maybe in organic class. Okay, you may heard about the hybridization. Okay, and the localized electron model. Okay, it means, okay, hybridization means the orbitals of carbon and hydrogen. Okay, they do hybridized, 就是混成轨域. Okay, so the electron was fixed, was localized between carbon and hydrogen. Okay, remember? Okay, so for example, the methane is the sp3 的 hybridization. Okay, sp 3的混成滚以外 because for carbon, okay, they already use s orbital and 3p orbital, okay, to react, to overlap with hydrogen's s orbital. So why it's called the sp3 hybridization. Okay, so here, for example, is another one, the model. Okay, this S is P, S, Py, and Pz. Okay, so when carbon, for example, like this, the methane, the molecule is known by the experiment to be tetrahedral. Okay, with the angle is 109.5 degrees. Okay, so if this is the orthogonal, it will be 90 degrees, right? But no, for the methane actually is 109.5 degrees. Okay, so it's not just like this. 90 degree, 90 degree, 90. No, it's like this. Okay, it's because the orbital hybridization. Okay, so we already mentioned about 1s and 3p get together, hybridization, okay, and finally this is what we call the sp3 hybridization. Okay, this is what carbon's s, carbon's p, 3p. Okay, so you may think like this one. Okay, this is the atomic orbital of the carbon. Right, there's a 4 electrons in the atomic orbitals. Right. Okay, then we already know the methane molecule. One carbon will connect with 4 hydrogen, and every hydrogen has 1 electron. Okay, so what we call is sp3 hybridization is because carbon use 2s and 3p. So the hybridization is what we call sp3. Okay, so this is they make it as a plot. Then you know, okay, it already get together, mixed together. Okay, sp3 is like this shape. Okay, so next is hybridization and localized electron model, figure 14.5. An energy label diagram showing the formation of 4 sp3 orbitals. Okay, so here, for example, is the carbon's p orbital, 2p. Is there any question about why they don't use 1s orbital? 为什么我们这边只看 2p？ 有没有人有这个疑问？Teresa, do you have any question about why we just only use carbons 2p and 2s and 2p? Why not the 1s? Is anyone can explain it? Try to speak in English.
Valence electron.
What kind of electron?
Valence.
Valence electron. Okay, you understand? The valence electron is the most outside electron. For carbon, there's 1s, 2s, and 2p, right? And remember, we say N is principal quantum number. Okay, and when N is increased, okay, the number of N increased means the energy increased. Okay, so here, 1s should be here. I mean, the lowest energy of carbon's atomic orbital is 1s. So it's inner field. Okay, so since it's the lowest energy of the carbon, okay, we won't be able to take the electron from it. Okay, all we can use is valence electron. 了解吗，电 ？OK， 好，价电子 valence electron。OK， 好，所以这边为什么我只用2s 跟2p， 没有去讲到 es？ 为什么 ？It won't change. Okay, it won't be changed. Okay. So, and hybridized, it will become 4sp3. Okay, because 1 2s plus 3 2p. So when they hybridize, all they are called sp3, and what? And the number of the hybridization orbitals is equal to number of the original orbitals, the sum of original orbitals. Okay, so there are 4 single orbital. When they do hybridization, it will form 4. Okay, hybridization orbital. Okay, it's the basic concept. Then here there are 4 directions that they can, react with the hydrogen's 1s orbital. Okay, for example, like what I draw here, right? So it's pair. So basically, total is what? 2, 4, 6, 8. Okay, it's totally, there are total 8 electrons. So they will, predict the methane is the stable molecule. Okay? So it's not difficult, right? Okay, so you say, write describe the bonding in the ammonia molecule using the LE model. Okay, LE model. And remember, in the end of chapter 13, we also talking about the LE model, right? 13章的后面我们有讲到 LE model. Okay, but here we talk it more. Okay, so yeah. Then, if you use the LED model, then you will know you have to pay attention to the lone pair. Okay? For example, like this one is the 90 degree, but lone pair here is bonding pair. There is a lone pair bonding pair repulsion. Okay, so that's why finally it will make the ammonia as what? As the trigonal pyramidal. 角锥形 Okay, so you can use the hybridization to what? to explain the shape of the nitrogen, okay, and the lone pair. So actually here he wanted to explain since we already know the methane is like this, right? Tetrahedral, right? Then when we change it as ammonium, just this H is not H anymore. They use what? It's a lone pair. Okay, so no wonder based on this is the trigonal pyramidal series 三角锥的结构，了解吗？好 ，OK， then sp2 hybridization， okay, sp2 hybridization. Did I read my cell phone? No, right? It seems I heard something is bing, 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 bing. Okay, maybe not. Okay, so here, sp2 means there are only py and what? What's this? ps and py. Because remember the double bond. We can double bond is formed by 1 sigma, 1 pi, right? Then sigma is formed by what? Head to head, S to S, or PZ to PZ. Okay, but the pi bonding is what? This is the head to head, right? And it should be the what? Side by side. Okay, so there are only PS and the PY. Can form pi bond. Okay, so here, let's see. The s orbital and the what? The two p orbital, one is ps, one is py. Okay, so when they hybridization, they will form the sp2 hybridization. So it's like the plane, 它是平面的 see? Okay, the simplest case, the example is like a thing. 乙烯 okay, 乙烯 okay, so let me check this. Okay, so here sp2 hybridization same. Okay, 2s 2p hybridization, there's become 3 sp2 and there's another 2p. What is this 2p? It's pc. Remember? Only this okay, can form pi. Okay, so 2s and 2ps and py, 3 orbitals form 3 sp2. And I still have